So today we will go for the rectifier. What is rectifier? What is rectifier? Meningkatkan, to increase, to amplifier. Convert current. Okay, boleh lah convert current sikit. Kalau tu meningkatkan tu dia amplifier. Dia ya tu dah lebih kurang. Yes, it is actually our main purpose is to get the DC signal. Okay, the DC power, DC voltage kita nak. Okay, and the rectify is actually to set right ataupun to put something at the exact place or exact value. Okay, and it is part of the power supply circuit, and also we can use as the power distributions and for sensing of amplitude for modulated radio signal. It is actually kita nak cater in between of daripada supply yang kita ada daripada TMB. It is AC ke DC? AC. Berapa volt? 240. Kalau kena 240 apa jadi? Terkejut. Terkejut je? Apa cut? Okay, tapi all our equipments kita yang kita pakai ni AC ke DC? DC. So kita kena ada transition kat situ. Apa nak buat supaya signal yang masuk ni adalah signal DC. Why all our equipments tak guna straight away the AC power? Because for the AC voltage ataupun the current, it is actually not stable. Why it is not stable? Because signal AC macam mana rupa dia?
Sine wave.
Yes, sinusoidal sine wave. Okay, continuous signal. Okay, dia ada positive and negative signal. When we have sinusoidal sine wave, dia kena ada phase kan? Dia kena ada frekuensi. Okay, so bila kita nak hantar signal tu, nak tengok amplitude dia lagi. Ada positive, negative amplitude pula. Maximum and minimum. Okay, maximum peak, minimum peak. Okay, from the VP and to the minimum VP, dia ada VPP. Okay, so we have lots of parameters to consider. We have the frequency. Okay, and we have positive and negative cycle. Okay, this is for AC signal. Meanwhile, for DC signal macam mana rupa dia? Straight line je. Okay, and this is more stable. Kenapa? Kenapa ID? Apa beza dia? Tadilah dah cerita dah kan? Tak ada. It just beza dia kalau in terms of the signal macam ni, and then macam ni the DC. But then actually for the equipments yang kita pakai, home appliances, semua DC. Okay, and I think kalau dekat luar pun, dekat power base station, so dia DC, tapi dia ada stock up punya relay yang untuk convert the signals daripada AC untuk transition. Okay, yang kita dalam pipeline tu semua tu, itu adalah transition lah signals tu, yang TMB punya wire tu. Okay, that is yang kita convert tu AC. Tapi bila kita dah sampai for the applications untuk usage, kita guna DC. And then dekat rumah kita kalau kipas berapa volt? 240 ke? Kan? Okay, do you know how many voltage for your charger? Nak charge handphone, laptop? 5 kan? 5 for laptop. 5 for charger handphone, laptop 20 kot. 15, 20 macam tu lah. Kalau tablet 12, 15. Dia in between. Okay, so that is why dia kecil je sebenarnya. Kita nak guna the voltage dia kecil. Maybe kalau macam peti, mesin basuh itu besar sikit lah, tapi tak sampai 240. Okay, so we are not using the high voltage supply supaya kalau jadi apa-apa kan meninggal pula kat situ kan. Okay, so it just kalau nak charge benda-benda macam ni, kita perlukan voltage yang rendah. So kita kena rectify the signal so that it is applicable and just enough. Tak adalah bil melambung-lambung. Padahal kita nak pakai sikit je. Okay, so itu adalah few benda-benda yang need to be considered. Why kita guna the rectifier, the voltage regulator. Okay, depends on the applications lah. But then this is for usage applications, harian punya barang-barang in your surrounding lah. Okay, so that is for the AC and that is for DC. Okay, so apa lagi? For the DC, we have the okay, for the rectifier, we have two types, half wave and also for full wave. Kita akan cover for these two types of rectifiers in chapter 2b. Okay, and for this rectifier, we use the diode. Kita apply diode in the circuit for the applications lah. Okay, diode is two terminal devices which has the non-linear relationship, current flow through, and most important is diode is only one way direction. Current boleh lalu in one way. Okay, applications of diode is in the design of the rectifier circuit. Kita tengok on the circuit. Okay, and we know that diode can perform switching. So when it is in on condition, it is closed circuit. Okay, closed circuit, so the signals can pass through or the current can flow. Okay, this is open circuit. Okay, the current cannot flow. I is equals to 0. Okay, and for this one, this is in forward bias condition. Kalau untuk for the diode lah, condition dia macam tu. Kalau this one for reverse bias, it might be terbalik macam ni. So the current cannot flow because the characteristic of the diode is only one way direction. Okay, so kalau kod situ current tak boleh flow. Okay, so that is why dia jadi off and open circuit. Okay. Okay, so this is the simplest type of rectifier circuit is half wave. For half wave, we only have one single diode, one diode in a circuit. Okay, this is sine wave yang kita ada tadi, the AC. Remember, now we want to get the DC straight line. So there is few process before we can get the DC straight line. Okay, so this is the AC signal from the supply. For the half wave, this is positive cycle kan? Yang bawah is the negative cycle. Okay, for the sine wave kan dia ada positive and negative cycle. Okay, so for the half wave rectifier, it only rectified for the one cycle only. If the signal is for positive cycle, so you can only get this one. Okay, for the negative cycle tak ada. If it is for negative cycle, so it only can get yang belah bawah aja. Either way lah. Okay, one operation only one cycle for half wave. Okay, kalau for this is the circuit for half wave. Okay, this is the type of circuit in which a signal rectifier diode is applied with a time varying sinusoidal signal, this one, input, AC signal input to generate a DC output having a value half of the input. We call it as the half wave. So this is the circuit actually. Dia akan lalu from here goes to this one. Okay, so only one diode. Okay, the input is a sinusoidal waveform or it also can be in the terms of the square wave. Tak kisahlah, as long as it is a AC signal. Generate the waveform of the V out at the resistor which will have an average value of the particular use to AC. So this is, kat sini lah sebenarnya dia akan cut. Okay, only conduct when it is in forward bias. Okay. So that is how dia boleh dapat one cycle sahaja on one direction. Okay, this is for VDC. This one, dia sebenarnya belum betul-betul pure VDC. That is why for VDC equals to 0.318 VM. Okay, the period, mana period? Okay, this is the period here, T over 2. The polarity of the VI become negative and cause the diode to turn off, and then for this condition, this is when the apply kod terbalik and then off. For this cycle yang ni tadi, for the next negative cycle. If it is for positive, so the negative cycle dia jadi tak ada because of condition for the diode. Okay, so for this one, DC, VDC equals to 0.318 VM. VM is the peak voltage of this point kat situ. Okay, because we want to get the new value of voltage kan, so it is not the same as the AC voltage. Okay, you guys ada belajar in EPE juga kan? Sudah lupa. Okay, 0.318. 0.318 it is, cuba you kira 1 over pi dapat berapa? Okay, VDC equals to VM over pi. That is the formula. So it is the same thing pun sebenarnya ni. Kan, dapat tak? Okay, so it is the same thing. This is for ideal diode. For ideal diode value. Okay. So kalau ada, if we have continuous signal, so it will become like this lah, the signal. Okay, half wave rectification is a process in which one half of the cycle and eliminated by the diode of its output. So the cycle yang dia tak rectify will be eliminated. So you can get only this signal. And the VDC is this one. Because purpose kita final nanti nak dapat straight line je. Okay, tapi now we still have the VM in the value dia, in the formula dia lah. Okay. Okay, this one, we have this circuit determine the level of the output. Okay, so this is the formula tadi. So this is the VM 20. So you just apply in the formula 0.318 1 over pi. Okay, so you get this value, meaning that bila dapat the negative, it is for yang bawah lah. Okay, for the negative cycle because of the reverse direction, because dia ambil from here. Okay, the directions of the diode terbalik. Because for this one, the circuit diode, the diode dia macam tu kan. Yang tadi, the first one yang tadi, diode dia macam ni. So if this one akan dapat positive value, this one will get negative value, meaning negative cycle. This one is positive cycle. Okay, tapi circuit dia lebih kurang, it just polarity of the diode saja yang berbeza. Okay, so dia akan dapat like this lah. Since it is for negative cycle, dia akan dapat like this one untuk sebelah bawah. Okay, because this is VDC equals to 0.318, this is minus VD. Okay, for ideal diode, kita tak ada minus VD because we consider it is 0. If it is silicon or germanium, so we need to minus, this is minus VD, 0.7. Okay, using a silicon diode, so minus VD, V silicon. So VM 20 minus 0.7. Okay, VM, this is value of the VM. So you just plug in the value of the VM, you get the final VDC yang sini nanti. Okay, minus kat bawah dia lah. Okay, Vm equals to Vmax minus VD for silicon, if it is silicon. If it is germanium, then you need to minus for germanium. Okay, so for here value dia agak besar because the Vmax is 200. Okay, the Vmax, the supply of the AC signal yang asal tu is 200. So dia akan dapat besar lah the value. Okay, this is the final answer bila kita dapat on the negative cycle only. Okay, this is the trace effect of the VT. VT is the VD voltage of the silicon tadi tu. Okay. Alright, so tadi is half wave. Half wave is only either positive or negative cycle. Okay, so if we go for full wave, okay, it can convert high AC to low DC. Maksudnya if we want 5 watts only, so we can use this full wave juga. And for full wave, rectify the entire cycle for both positive and negative. Okay, and for half wave, we only have one diode kan. Okay, minus VD je. For full wave, use 2 diode. When we use 2 diode, mesti minus 2 VD lah. Tengok dekat dalam the circuit. Kalau lalu 2 diodes, meaning that minus 2 VD. Okay. Or also sometimes called as the center tap full wave rectifier circuit. Okay, this is for the output. This is input and this is output for full wave. Maksudnya for both positive and negative cycle akan dapat yang belah atas je semua. And nanti we are targeting to get the straight line. Okay, of the DC signal. Alright, so this is one circuit of the full wave bridge network. Okay, for bridge network, the VDC, just now VDC for half wave berapa? 0.318 equals to 1 over pi kan? Okay, but since this is full wave, dia guna for both cycle and we use 2 diodes, 0.636, the double of the half wave. Okay, double from the half wave tadi. Alright, so kat sini we will have 2 directions. Now we have 4 diodes, D1, D2, D3 and D4, but only 2 diode will be active in a single direction. Single laluan. Okay, lalu here, goes here. Dia akan pergi mana pula? Kiri, turun. Okay, this is path 1. Okay, kalau path 2, I will change my pen. Okay, path 2 kita tukar this one. Ni negatif, ni positif. Dia pergi sini, goes D4, kiri, keluar. Okay, so for both directions, still we need to lalu the R0. That is why they measure the V0 dekat the R. Okay, both directions akan lalu 2 diodes. Okay, 2 diode will be active for a single time. Okay, this one goes here, on, lalu sini, on, habis. Okay, ni satu laluan. Yang ni will be off, the other will be off juga. Okay, so from one path we'll get for one cycle. Satu path, satu cycle. Okay, so if we want to get the signal kan dia ada cycle bawah pula. Okay, if we want to get for the second cycle negative, kita tukar the polarity. Polarity of the supply, and then yang mana forward tadi akan jadi reverse. The reverse will be forward. Okay, so dia akan lalu for this one, pusing. You get this untuk second cycle tapi dekat atas pula. Okay, and then bila kita continuous process tu, dia akan sambung lah all the signals. And all the signal will be positive value. Okay, for DC signals, dia tak ada negative. VDC dia tak ada negative. Okay, VAC dia ada Vmax dia ada positif ada negatif kan, because we have two cycles, positive and negative cycle, betul tak? ID dia dah menggaru-garu. Okay, dia macam banyak teori sikit. Dia macam banyak teori sikit. Dalam soalan test jaranglah kita tanya benda ni sebenarnya, tapi on the objective part A, boleh je nak tanya. What is rectifier? What is the purpose of half wave? How many diodes will be active for bridge center tap rectifier? Okay, itu adalah benda yang it can be asked lah. Okay, so this is the formula for full wave rectifier. Okay, dia berbeza daripada tadi. For just now 0.4 for half wave 0.318 Vm minus Vd. Okay, that is for half wave kan. Okay, so yang atas is for full wave. Okay, so beza dia dekat sini and dekat depan tu. Okay, because two diode at one operation time. Okay. Okay, so this is also called as the bridge rectifier circuit, but then only have one diode. So satu laluan yang ni. Okay, and another one we need to tukar dia punya polarity. So it will flow this one. Okay, so this is second, the red is the first. Okay, masuk sini. The green masuk here. Okay, so for each path you can get the calculations. Okay, this is actually represent through this one. We have the 2 ohm, lalu kod 2 ohm juga, and this is actually in parallel with the another 2 ohm resistor. So this is to get on the V out at the 2 ohm resistor. V out dekat sini sama dengan V out dekat sini because it is in parallel. Okay. Okay, so this is for another path to get for the negative cycle. Okay, sama juga. Yang just now dia two parallel dekat depan. Yang ni kan. Okay, this one. Two parallel resistor dekat belakang. Okay, but then still same operation. Okay, dia akan lalu because dia akan lalu here, goes here. This one pula yang off. Okay, so that is untuk dapatkan for the negative cycle, and this is the output. Okay, this will be the output of the negative cycle. VDC is, this is VM kan, supply dia, yes, VM. The supply here is 5, so that is why dimasukkan 5 kat situ. Okay. Alright, so this is the next one. We have the transformer. Okay, still on for the full wave, but then we use the transformer connection in the circuit. Okay, for the transformer need to be careful because we have the winding. This is primary kan, this is secondary kan. Kat mana belajar pasal transformer? Mesti ingat lagi kan Intan? Dulu belajar EPA dengan siapa? Oh, Dr. Farid Misnan. Ke Farid apa? Syed Farid? PKE, yes. Because when it is code EPE, dia adalah code electrical. Kalau code CSC, computer science. Code MET from FSKM. Sekarang FSKM ke apa nama dia? Pula. Okey lah. Panjang nama dia. Okay. Alright. So this is for transformer. For transformer, you need to know on the winding lah. From primary and secondary. Okay. this is for this one here, kita ada dua. Okay, yang atas we have two diode. This is for positive cycle. Okay, if it is flow yang bawah here, this one meaning that we need to change on the polarity lah. This is for negative cycle. So only one diode will be on for each cycle. Each time only one diode will be turned on. Okay. Okay, for positive half of the AC signals, this is for the first one. During positive cycle, the VI applied to the primary, this one, of the transformer appear as dia akan dapat for this one. Okay, and this is the second output pula. Okay, sorry. For this one, dia tak dapat lah because this is off. Okay, this is on yang atas dulu. Okay, so they will flow for here, this one. Okay, and we get this, the first cycle. Okay, for this one, current cannot flow lah kat sini. There is no current flow because it is open circuit. Okay, and the second one is yang ini pula off. So the current can flow for this one pula. You get the second one. Okay, so only one diode will be on accordingly lah for each process. This is after rectified. Okay, this one is before rectified. So dia ada beza. Kalau before it is negative cycle, for after dia akan jadi positive cycle. Okay. Okay, so this is the voltage waveform. We have, this is the input, the AC signal lah. Okay, we have the Vmax. This is the Vmin. Okay, and voltage will waveform across the secondary winding and across resistor when the input sinusoidal is applied at the primary winding. So we need to take considerations on the winding ratio. So dia boleh jadi step down ataupun step up. Okay, depends on the value yang dia bagi. Okay, so for this one, since from 2 at the primary, secondary is 1, maksudnya dia step down, dia jadi 0.5. So kena kira lah. If it is in primary is 100, so in secondary the supply will be half of the primary. Okay, if the step up 1 to 4 ke, so you kena darab lah ratio dia jadi berapa. Okay, so this is the primary 100 min. Okay, and max. Okay, but now here since kita ada dua pula, okay, all this dia akan jadi 50 kan, tapi kita ada dua, so each akan jadi 25 lah. Sebab tu kat sini dia jadi from 100 dia jadi 25. Okay, and this one, kenapa dapat 24.3? Because in the circuit we have this diode. Okay, we have the diode. We have D1 and D2 for each of the positive and negative cycle. Okay, satu diode will be turned on for positive cycle, another one will be turned on for positive cycle. That is why kita dapat the value is 24.3. Okay. What else? Sikit je actually for this rectifier, but then you need to understand on the applications of the diode lah. Okay. Okay, so this is kind of recap what we have learned today. We have the half wave rectifier. What is 0.318? Ideal 1/pi. Okay, so what if bridge rectifier and center tap rectifier? Full wave. Okay, this is two types of full wave. Kenapa the bridge tu kita panggil bridge? Because ada apa kat tengah, Intan? Ada resistor. The resistor will act as junction lah. Okay, from one diode dia lalu situ and goes to the other diode kan. Okay. And then for the center tap transformer, yes, dia ada transformer lah for sure in the circuit. Okay, so this is for ideal diode. This is for the real world diode. And actually for the ideal diode memang takkan ada pun the value. The diode, each diode must be ada value dia. Okay, that is why kita kena tolak this one. Okay, tapi sometimes dalam soalan in theory ada je dia tanya what is the ideal diode. That is why kalau for the ideal diode, the IV characteristic dia macam ni sahaja. Dia on the origin. Okay, on the axis X and axis Y. For this is I, this is V. Okay, and then this one Y minus 2D. Terus malaikat lalu. Y Nafis minus 2D? Ya, full wave. Tapi Y minus 2D? Dia ada dua apa? Yes, two diode. Okay, dalam path laluan dia tu, dia akan lalu in two diodes. That is Y minus 2D. Kalau jawab sebab full wave, yang ini pun full wave juga, Y minus VD saja. Okay, in the path dia cuma for this one, in the circuit dia cuma lalu for one diode. Vmax ni kan. So this is Vm. Okay, ataupun we at the peak lah, we peak itu. Okay, alright. So itu saja actually yang penting. Yang hujung here, okay, awal. Okay, yang hujung here is on the peak inverse voltage. This is actually some there is condition where it is cannot be solved with a single directions of the diode. So kalau kita cross signals current in a diode, they might happen when the diode tu rosak. Okay, so what we can do is kita boleh guna Zener diode. Okay, the Zener diode, it is the diode that can be operate in the reverse voltage. Okay, for reverse bias. Okay, for that condition there is avalanche breakdown ataupun reverse breakdown. So yang itu kita akan belajar dalam 2D nanti. Okay, for the Zener diode. Okay, Zener diode. Simbol dia lain sikit dari diode biasa. Dia ada so dia ada yang ujung tu, dia ada this one. Dia beza sikit. Yang dia ada macam gitu. Okay, that is for Zener diode lah. Okay, and then kat sini just yang sama macam tadi for half wave Vm, and then this is for the bridge rectifier diode. This is for full wave center tap. This is all the circuit macam yang kita dah tengok tadi lah. So why it is important for us untuk guna the diodes in the circuit? For sometimes the diode can be act as a safety protection juga. Okay, we have the protection, sometimes kita panggil as protection circuit. Okay, normally in the protection circuit, diode mesti ada inside. Okay, in one of the components lah. Okay, contohnya bila kita on TV tapi ada lightning kat luar, ada guru-guru semua kan. So what the diode will do bila dia sambar dekat the signal, so diode tu the components lah, diode is one of the components in the protection circuit. So dia akan groundkan terus the signal so that kita punya equipment tak rosak. Tapi ada juga conditions where equipment kita rosak. Sometimes kalau yang jenis macam tu, mungkin the signal yang kilat tu terlalu tinggi ataupun protection circuit kita tu yang dah rosak dulu. So equipment yang rosak, rather than the equipment yang mahal-mahal yang rosak, so biarlah the protection circuit tu yang dah cut down lah. Okay, the signal yang tinggi, so that alat kita tak terbakar. Okay, microwave tak terbakar, TV tak meletup. Okay, so itu adalah antara among some of the functions lah. And also kalau kita mengalirkan some arus yang tinggi, everyday barang-barang you nak pakai, nak cocok ni, dah kalau voltage dia dah 100, tak ke bahaya pula kan. Okay, so itu adalah functions of one of the diodes lah. Okay, alright.